Hello everyone, I would like to continue with the previous video. We were working with the area as a parabola open to the side, and this is our boundary of y equal to 2, y equal to 1, x equal to 0. So let's label that. Okay, so this is y equal to 2, y equal to 1. Yes, okay. And this is the x equal to 0. Okay. And this function right here is y equal to the square root of x minus 3. So after we indicate the area that we have to work with, and because we have to rotate about the x-axis, so we are going to choose the element that is parallel to the axis of rotation. So in this case, we are going to have the horizontal element, and it will be our dy. Okay, so right here is our dy. Because of the dy, we are going to choose the appropriate formula to work with. And if we rotate this about the x-axis, we will end up with the shape like this. Okay, so it's just like if you take a look from the top down. So this is the part that I'm talking about. Right here is our so this part right here is in fact our um, parabola open to the side. All right, okay. So let's show everyone a few more image. So this part is the hollow part. Okay, it's a hollow part that we have right in the middle, right here. Okay, so let's move to the next one. Okay, so now you see this is when I put this in this position for everyone to see. So this one I put it in the position so I can draw a graph to it. Now I stand it up, and this is the cross section half of it, and if it's the whole circle, it will be like this. Right? Okay, so let's take a look at another picture. So if is the from the look at the bottom, you can see that is the circle with the hole. And where's the hole coming from? The hole is actually from here. All right, okay. So because you are not talking about the area, we are not talking about the area between y equal to 0 and then y equal to 1 in this case. So our area is like this. So when we rotate it about the x-axis, we will have, it will be hollow. All right. Okay, so let's get back to our lesson. And we are going to continue with example number 2. Alright, so for this particular example, after we indicate the area, we found the formula that we have to work with. So in this case, I'm going to, instead of writing Fy, I write it equal to x. So that it reminds everyone that I need to solve the function for x. And I did it in this case. Okay, so you're going to solve the function for x. And then you multiply that with the y. So in case you make a mistake, you know that if you are work with the differential factor of dy, then you must have all the variable in here as y. And how do we know that we are working with dy? Because the element that we are going to choose in this case is the one that is parallel to the axis of rotation, because we are using the shell method, and it's the dy. Okay, so let's continue with our example number 2. Okay, on this step in between here, so our integration review and apply definite integral and fundamental theorem, then we should be fine in terms of integrating. Okay, so now for example number 2, I have to use the shell method. So I'm going to draw the symbols here to remind myself that I am going to use the concept of parallel to my axis of rotation. So in this case, it will be the y-axis, So y-axis, so I'm going to draw that to remind myself that I'm working with the y-axis. Okay, so the given curves is this: y equal to 3x squared subtract x to the exponent 3, and it's drawn for us right here, and then y equal to 0. Okay, so y equal to 0 is the x-axis, so this part. So let's circle that, highlight this part right here, and here is my y equal to 0. So this one is y equal to 3x squared subtract x to the exponent 3, and this one is y equal to 0 is the equation for the x-axis. So if I highlight the area, and then because I have to use the shell method, I'm going to draw the element that is parallel to my axis of rotation, which is the y-axis. So in this case, I am going to use the vertical element, so it is dx. So this particular example doesn't give me the upper and the lower limit. So now you see with the dx, you have to figure out this point, right, and this point. So this could be your upper limit and the lower limit. And right here is definitely equal to 0. And we have to find this point right here. So for me to find this point, I will have to let this two equation equal to each other. So I need to have this equation here and this equation here equal to each other, so I can find the point of intersection. So before we are going to do that, let's write down what formulas that we have to work with. Okay, so go back to the beginning of the lesson. You have two formulas to choose from. Okay, so this is about the x-axis, and this one is about the y-axis. About the y-axis, we are going to use these formulas. Alright, okay. So this is very obvious here because I'm listing this below saying that about the y-axis. But if you need to work with your formula sheet, okay, so this formula sheet right here, then you have to realize which formula to use in this case, right? So this is the shell method. Either you use this or you use this. So in this case, because I have dx, so I must use these formulas. And in this formula sheet, you see I put here as the y. So that means you must solve for y. Alright, okay. Let's get back to our example. Excuse me, I'm sorry. I think I will have to drink some tea again. Okay, so please let me pause and then drink my tea. Again, I keep telling my student that tea and math, they go very well together. Okay, thank you. Okay, so the formulas I'm going to use is volume V equal to the integral from A to B. I am using the shell method, so I have to get the 2 pi's and x times y times dx. So in this case, what I need to do is I'm going to make a note to everyone. So dx, okay, parallel to the y-axis. Okay, so dx parallel to the y-axis. And what is y in this case? Okay, so when it is a y, then I am going to make sure that so right here I put the y and you multiply by this, so that means whatever y equal to, you are going to substitute into here and you isolate the y, therefore is your function will be in term of x. So this should be the fx. So I don't want everyone to get confused between the fx and the fy. This fx here show you that the function has to be in term of x or with respect to x. So that means you are going to isolate the y. You're solving for y. And whatever y equal to, you substitute into this for y. Okay, so let's figure out our point of intersection. Okay, then I will let these two equal to each other. So I have y equal to 3x squared subtract x to the exponent 3, and it's given to me as y equal to 0. You see, it's very logic. Okay, so because both of this equation is equal to y, then I can just let them equal to each other. Okay, then solve for x. In this case, I will have a few values for x. Okay, so in solving for an equation like this, I'm going to factor out the x squared. X squared, so I have 3 minus x left is equal to 0. Okay, at this point, I would like everyone to know this. This one you are going to multiply, right? So that means you are going to argue. You're going to have either x equal to 0 or you can have 3 minus x equal to 0. What I mean by argue, because if you multiply two functions together, you have x squared, you multiply with this expression 3 minus x. In order for you to have 0 on this side, then either x squared has to be equal to 0 or 3 minus x equal to 0. Okay, so it's better to factor and then to use that argument in order to solve for x. So in this case, I will have x equal to 0 or x is equal to 3, right? So 3 equal to x in this case. So there's I have the two values for x. So this is 0 and this is 3. So my a is 0 and the b, the upper limit, is equal to 3. After we get all this, we are going to write this as our integral v equal to 2 pi multiply with the integral from 0 to 3 of x. Okay, now is x times y times dx. What is y equal to? Y is in fact equal to this right here. So that means I am going to put it as x multiplied by 3x squared subtract x to the exponent 3 dx. Okay, so the rest is simple. The rest is simple because we already know how to integrate and we already know how to apply fundamental theorem. Okay, so that multiply that in, I will have this equal to 3x to the exponent 3 minus x to the exponent 4 dx. So I will integrate each term individually. Okay, so I write 2 pi times, okay, 3x to the exponent 3. Add 1 to the exponent 3, which is 4, then divided by that. So 3 over 4, x to the exponent 4. Add 1 to the 4, which is 5, then divided by 5. Okay, apply fundamental theorem from 0 to 3, close the bracket. So that means volume will be equal to 2 pi. And in this case, I want to tell everyone that you must multiply that with f of 3 subtract f of 0. Okay, so then I have v equal to 2 pi multiplied by, okay, so I will have 3 over 4, where the x is will be replaced by the 3. Where the x is, replaced by the 3. Okay, so so I can write the 4 out here just to make sure. So this is my f of 3, okay, and you know that f of 0 will be 0 because 0 substitute in any of this is also 0, but I just want to make sure that I write it down as well. Okay, so close this. So this is my f of 3, and this is f of 0, which is equal to 0. So I'm going to ignore that second part. So then I don't give myself enough space here. then I will have V equal to 2 pi times 243. 243, that means 3 to the exponent 5, okay, divided by 4, subtract 3 to the exponent 5 is also 243 divided by 5, so it should be equal to this number. I am having this as 2 pi times 243 divided by 20. I am going to cancel that with that. So then my answer will be 243 pi divided by 10, a unit Q. Okay, so this will be my final answer. Okay, 243 pi divided by 10, unit 3. Unit to the exponent 3 because we are working with volume. Alright, okay, so let me recap what we have done. Okay. So for the shell method, what we need to do is remember that unlike the disk method, shell will be the complete opposite. Okay, so take a look at what axis of rotation that given to you. If it's given to you as the x-axis, then you must choose the element that parallel to this x-axis. So in this case, you are choosing this element parallel to x-axis. You know it's a dy. With the dy, you are going to choose the formula that involve a dy. And then again, based on the axis of rotation, you figure out your element, and from your element, you are going to figure out the formula that you are going to use. So in this case, I think this should be the dx. I make that error right there. I'm sorry, everyone, but I'm glad that I have a chance to correct it here. So this is my dx because it's a vertical element. Okay, so with the dx, you are going to use these formulas. So determine the area, finding the element. This will be the indication of what formula that you are going to use, and then make sure that if it's the x, then you are going to solve for x, and your equation will be in term of y, or with respect to y, substitute in here, then we go from there. Okay, so that example 1 that we done in previous video. For example 2, what we have is we have y-axis here, so we are going to draw that to remind ourselves that we rotate about the y-axis because we have to choose the element that parallel to this axis, so it's the dx. Okay, so for this particular question, it doesn't give us the upper and the lower limit AB, so we have to solve for that by letting these two equations equal to each other. Letting it equal to each other, solve it, we have the two values x equal to 0 and x equal to 3. So having x equal to 0 and 3, substitute them into this definite integral, and because you are multiply x with the function in term of x, which is fx, now you see that is equal to 3x squared minus x to the exponent 3. Expand this so that you can get the correct integrand to work with. Integrate this and apply fundamental theorem, and in the end leave your answer as exact with a pi. Okay, so don't try to get a decimal out of this, just make sure that you leave your answer in fraction form as the exact form, and simplify as well. So I have a few questions for everyone to try. I drew the graph for everyone also, but I take the grid out because then I would like everyone to go through the process of finding the point of intersection. Okay, and there's 2 questions for you to work with. Okay, alright, thank you everyone.